Hey everyone, and welcome back. In this one, we're going to have a look at the different types of data that we'll come across, as well as the different data analysis stages, which are a really good framework and order of events for you to follow when carrying out data analysis work. Let's start out by having a look at the data analysis stages. As with anything, starting from a completely blank slate can be quite difficult. Thankfully, this is where the data analysis stages can help. These are basically just a series of structured stages and steps that are designed to take us from defining our objectives to presenting our findings. There are 5 main stages to be aware of: defining our objectives, collecting the data, cleaning our data, analyzing the data, and finally visualizing the results, carried out in this order. And let's now have a look at each of these in a bit more detail. First off, we need to define our objectives and problem statement. So what problem are either you or your manager trying to solve, and what outcome would be classed as a success? As an example, let's have a look at a common email you might receive from your manager. This question doesn't help us at all with getting a clear idea of what the issue actually is. A very standard and common phrase that you'll hear used is SMART questions, which stands for specific, measurable, actionable, related, and time-bound. So instead of the question that we got before, a better question would be, can you analyze why our sales fell off last quarter and provide a report with key factors and actionable recommendations by next week? This paints us a very clear picture of what the issue is, what we need to do, and when it needs to be done by. So a lot of the time, one of your first tasks will actually be to help your stakeholder to ask a better question, so that you can identify what question it is that you're trying to answer. After we define our objectives and questions, the next step will be to acquire the data that we need to answer that question. The data that you use can come from a variety of different sources, including internal databases, external companies, the internet, and the government, as well as a load of other different sources too. Then, depending on where your data has come from, you'll most likely have to carry out some data cleaning. Data cleaning is the process of fixing or removing inaccurate, corrupt, incorrectly formatted, duplicate, or incomplete data from a dataset. Usually, this will be the biggest part of your work, with an industry survey revealing that data analysts often spend anywhere between 60 and 70% of their time cleaning the data. There's lots of different things that we'll need to do and check for throughout the data cleaning process, and I've listed quite a few of these on screen here, but we're going to go through all of these in great detail throughout the course, so don't worry. After our data is clean, we can finally begin our analysis, which is the process of transforming raw data into actionable insights and information. At this stage, we'll be using any one of the 4 data analysis types that we went over in the last lecture, but more often than not, you'll be carrying out either descriptive or diagnostic analytics. Finally, once our data has been analyzed, we can then visualize our results, which is just the process of graphically representing information and data, and usually this just involves putting all of our analyzed data into charts that are easier to read and interpret. Okay, so these are the 5 main stages of the data analysis process. There are of course more nuances to each stage, but we'll learn about all of these as we progress throughout the course. I just wanted to introduce these to you now, so that you're aware of what the overall process is and the rationale behind what we're doing. And before we finish our lecture, let's have a quick look at the different types of data that you might come across. If we take this dataset here, we've got a bunch of different columns, all containing different data of different data types. The data type of the column will determine the type of analysis that we're able to carry out. So identifying and determining this will be an important step too. The first term that we need to know about is variable. A variable has a different definition in programming, but from a general perspective, a variable is just a characteristic, number, or quantity that can be measured or counted. Variables can then be broken down into two main types, categorical and quantitative. Starting out with categorical variables, these are often referred to as qualitative variables, and these just describe a quality or characteristic of an observation. And many of the quantitative or numerical operations aren't suitable for these types. Some good examples of qualitative variables include eye or hair colour, nationality, and occupation. Finally, we can also say that each unique value of a categorical variable is known as a level. For example, 3 levels of eye colour could be blue, green, and brown. We can break categorical variables down even further into binary, nominal, and ordinal, but we'll cover these in a moment. Quantitative data, on the other hand, is data that is numerically measurable. Statistical measures and functions can be used on this data, which provides us with a lot more analysis options. They typically answer questions like how much or how many. And then we can also break these variables down into either continuous and discrete. So let's have a look at these other categories now. Starting with our categorical variables, the first main type is binary. These variables can only take on 2 levels, such as yes or no, and 1 or 0. Nominal variables are another type of categorical data, and basically any categorical variable that's got more than 2 levels is classed as nominal. An important distinction about these, though, is that they can't be ordered intrinsically. For example, there isn't a logical way of ordering a list of people's favourite animal. Ordinal variables, on the other hand, are nominal variables that can be ordered intrinsically, meaning that they've got a natural ranking. Good examples of these include exam results, a satisfaction rating, and weekdays, because these have all got a naturally accepted ranking and order. Moving on to our quantitative data types, we've got discrete and continuous. Starting with discrete, these are variables that consist of separate, distinct, and countable values. Examples of these include the result of rolling a die, a product review rating, the amount of stock held in a warehouse, and number of employees at a firm. Continuous variables differ in that they can take on an infinite number of real values between any 2 other values. To illustrate this, height, weight, and temperature are all good examples, as in theory, we could go to any level of precision with these. Between 5'10" and 5'11", we could go to any number of decimal places between these 2 heights. And the same for weight and temperature. Whereas when rolling a die, you're limited to the numbers that are on that die, which is usually between 1 and 6. So that's the main difference between discrete and continuous variables. Okay, so that wraps it up for this lecture. I hope that this has all made sense. After this lecture, there's a quick quiz on data types, just so that you can go through and check your knowledge and understanding of what we've covered here. If you've got any questions, then please let me know in the Q&A section below. Good luck with the quiz, everyone, and I'll see you all back in the next lecture.